So here he says Rajan created a 5 by 4 matrix that had a distinct integer in each cell. He then omitted the numbers from the cells. And then the grid looks as shown below. A cell in the mth row and nth column is represented as m in. O denotes the presence of an odd number in the cell. The four cells at the corners have numbers that have exactly 3 factors, and the remaining numbers in the grid have exactly 4 factors. The sum of all the numbers in every column is the same. So let's have a look at this. So this is the table given to us. There is more information. I could not write all the information on one single page. So therefore, let's just figure out this information first. O denotes the presence of an odd number in the cell. The four cells at the corners have numbers having exactly 3 factors. What kind of numbers have exactly 3 factors? The numbers which are the square of a prime. They all will have 3 factors, right? And the remaining numbers in the grid have 4 factors. What kind of numbers have 4 factors? Either the cube of a prime or P1 into P2, that is product of 2 primes. You can see all these things in the chapter of factors. There it would have been discussed. And the sum of all the numbers in every column is the same. So this all we will just keep in mind while doing the questions. All this information I have written on this page. Let us start solving it. First of all, I see an information here that all numbers are less than 55. So what are the numbers that can come in the corners? Those are squares of primes. So square of 2 is 4, square of 3 is 9, square of 5 is 25, square of 7 is 49. I can't go above because I need numbers below 55. What about the other numbers? Other numbers would be either cubes of prime, that is 2 cube, or 3 cube, or 5 cube, but 5 cube would be greater than 55. So these are the only 2 cubes. Other than that, I can have product of 2 primes. Let's start with the smallest prime. 2 into 3, 6. 2 into 5, 10. 2 into 7, that is 14. Then 2 into 11, that is 22. 2 into 13, that is 26. 2 into 17, that is 34. 2 into 19, which is 38. 2 into 23, which is 46. I can't go above because I need numbers below 55, and the next number is 2 into 29. Now let's look at multiples of 3. So 3 into 5, that is 15. 3 into 7, that is 21. 3 into 11 is 33. 3 into 13 is 39. 3 into 17 is 51. Once again, I can't go above. Multiples of 5 are 5 into 7, that is 35 only, because 5 into 11 would not be less than 55. It will be exactly 55. And I can't have any other multiple of 7. Right? Now the point is that this table has got a total of 20 numbers, 5 into 4. 4 numbers are at corners. I need 16 more. And aren't these exactly 16? See, 5 plus 5 plus 5 plus 1. These are exactly 16. That means each of these numbers would come into the table. Each of the numbers would come into the table. Also, this column has the same sum as this column, which is same as this column or this column. So if I add all the 4 columns, I'll get the sum of all these 20 numbers. What is the sum of all these 20 numbers? When you do it, it gives you 512. That means sum of each column is 128. So I can say that these 4 columns are going to be 128. The sum of this column is 128. This is 128. This is 128. And this is 120. Now we have to fill up these values. Let's start looking at these now. The sum of all the numbers of the second row is the same as the sum of all the numbers of the fourth row. So their sum, let us say it is A. Sum of all the numbers of the fourth row is also A. The sum of the numbers in the last row is less than 100. So sum of the numbers in the last row is less than 100, which I'm writing here. Okay. What next? There are 3 numbers in the second column which have the same unit digit. And these numbers are in ascending order as we move down the column. 3 numbers in the second column which have the same unit digit. What can be the 3 numbers with the same unit digit in a column? In the second column, I can't have any number from these, right? So I will be having numbers from these. Among all these numbers, do you see any 3 numbers having the same unit digit? I see 6, 26 and 46. Do you see any other 3 numbers ending with the same unit digit? I don't see anyone else, right? That means this column should have 6, 26 and 46 in ascending order when you move down the column. in ascending order when you move down the column. And because 626 and 46 are used, so let me just remove them from here, that now they would not come anywhere else. What next? The numbers in cell 13 and 44 are two-digit numbers of the form AA. 13 and 44. These two are the two-digit numbers of form AA. Which are the two-digit numbers of form AA? They are 33 and 22. So I do not know which one is what. So 13 is either 22 or 33, and 44 is either 33 or 22. So these are the two possibilities that I have written now. These numbers are also gone. What next? The numbers in the cells 31 and 32 are obtained by reversing the digits of each other. 31 and 32 are this number and this number. They are obtained by reversing the digits of each other. So what can they be? Can you just have a look at once again? They cannot be 4, 9, 25 or 49. Reverse of 27. Can we have 72? No. Reverse of 10? No. Reverse of 14? No. Reverse of 34? We don't have that. Reverse of 38? We don't have it. We just have the reverse of 15 here, right? We just have the reverse of 15, which is 51. So one of them will be 15, the other one will be 51, one will be 15, other will be 51. So can I say the remaining three places now must be 6, 26 and 46, because this number anyways is odd. It cannot be 6, 26 or 46. This number is 51 or 15. This is odd. The other three now we got as 6, 26 and 46. By that, I can just remove it because nothing else is going to help me here. I hope you all got my idea here. Now, let us look at this column 2. 6 plus 26 is 32. 32 plus 46. 32 plus 46 is 78. So 78 plus 51 or 78 plus 15. One of them added with O will give me 128, right? The complete column adds up to 128. So either this 78 plus 15 plus O or this 78 plus 51 plus O. Let's try. 78 plus 51 is 129. How can 129 plus O be 128? That's not possible. So that must be 15. And also I know 78 plus 15 is 93. 93 subtracted from 128 is 35. So I get to know both the things now. Let me just remove it from here. I get to know about both the things, that this number is 15. That automatically means this number is 51. And I also got to know that this number is going to be 35. Right? I will have a 35 over here. So 35 is also a gone number. 15 is gone. 51 is gone. Even 35 is gone. I hope you all have understood. We have found out column 2 completely. Which number would appear where? That we have completely calculated now. Let us move ahead from here. Next number. Now he says the number in the cell 53 is not a multiple of 7. The number in the cell 53, that means this number, which is odd, he says it is not a multiple of 7. So it's an odd number, but not a multiple of 7. So which is the odd number which is not a multiple of 7 among all of them? You see, an odd number which is not a multiple of 7 is either 27 or 39, right? The odd number which is not a multiple of 7 is either 27 or 39. So this number is going to be, let me just write it here, that this number is going to be 27 or 39. Currently I cannot use it, so I am just leaving it here. It is either 27 or 39. What next? Fifth number. The number in the cells adjacent to 44. The number in the cells adjacent to 44. Adjacent to 44 means this cell, which is 22, 33, adjacent to this. But not in the last row. That means not this one. Adjacent to this, but not the last row. That means these two numbers he's talking about. These two numbers, he says, are perfect cubes. So can I say one of them would be 8 and the other one would be 27? If they are perfect cubes, one of them would be 8, the other one is 27. So 8 and 27 are also used because these two numbers are going to be 8 or 27. The adjacent cell is a neighboring cell in the same row or column. Anyways, we understood that these two numbers are going to be 8 or 27. Right? Finally, he says the number in 2, 3 is more than 35. The number in 2, 3. So number in 2, 3, that means this number is more than 35. So more than 35, what are the numbers that we are having? 2, 3 can be 38 or 39. So this number is going to be either 38 or 39. But I need another odd number over here, right? Another odd number is needed. This odd number, which is over here, now, this number can be what? This number also can be either 39 or 21 because I need an odd number here. I need a 39 or 21. So I need a 39. I'm sorry, I think I wrote 27 wrongly over here. Where was this? The number in the cell 53 is not a multiple of 7. Oh, yes. Now we have found this out, guys. This number which was odd, it was 27 or 39. 27 is already used. That means now we have figured out this number as well. So this number is going to be 39. This is sorted. I have got 39 as well. So that number which is 2, 3, this number, it is going to be more than 35. Now with the more than 35, I have only 38 left. So this number must be 38. This number must be 38. Okay. Now there is only an odd number which can come over here. The only odd number left is 21. So I will have to write a 21 over here. So this number must be equal to 21. This number must be equal to 21. Once again, now I see a possibility with column 3. Just have a look at column 3, guys. In column 3, 22 or 33 plus 38 plus 8 or 27 plus 39, this whole should be 128. So 38 plus 39, 38 plus 39 is 77. So can I say 22 or 33 plus 8 or 27 is 128 minus 77, which is equal to 51? 128 minus 77 is equal to 51. So which two numbers can add up to 51 over here? If you just look at this, are there any two numbers which can add up to 51, or I am making some mistake? This was 38 plus this is 13. Oh God, there is one more number over here. I'm sorry. There is another number over here which can come. Okay. And this another number which can come, it is either 34 or 10 or 14. 34, 10 or 14. Of course, 34 cannot be there. So this number can be either 10 or 14. This number can be 10 or 14. So what can add up to 51? One possibility that I see is 8 plus 33, that is 41. 41 plus 10 is giving me 51, right? 33 plus 8, 41 plus 10 is giving me 51. Is there any other possibility? I need a 51. See, this is an odd even number. So I need an odd sum from these two. And how can I get an odd sum, an even and odd? So either 33 plus 8 or 22 plus 27. But 22 plus 27 is not giving me odd. So the only possibility is 10, 33 and 8. I think we are very close to the solution now. So I have to write 33 here. That automatically means I have to write 22 here. This is 33. So this would be 22. I will have to take 8 from here. So I'll have to write 27 here. So this is 8. This is 27. I have to write 10 over here. There is no other possibility. Right? A lot many things have already been sorted now. I hope you all can see that. And now we have also used 10. We are left with 14 and 34 only. Just look at these two sums now. Row 2 and row 4. What are their sums? The sum of row 2 is 26 plus 38, which is equal to 64. 64 plus 21, that is equal to 85, plus this number, which is going to be here. Row 4 is 35 plus 8, which is 43. 43 plus 22. 43 plus 22 is 65, plus this number here. So these two sums are equal. That means this number should be 20 less than this number. And the two numbers left are 14 and 34, out of which 14 is 20 less than 34. That means this number should be 14. This number should be 34. And yes, we have figured out all the numbers except the corners now. Except the corners, we have figured out everything. How do we figure out the corners? Now look at the sum of column 1. What is the sum of column 1? Column 1 is 14 plus 51, which is 65. 65 plus 34 is 99. So I need a 27 from these two, right? 29 from these two. So one of them will be 25 and the other one will be 4. Similarly, from here, one of them would be 9 and the other one would be 49. The last thing we can use is the sum of the last row is less than 100. I already have 46 plus 39, which is equal to 85. With 85, I can only take 4 and 9 so that the sum is less than 100. If 4 is here, 25 is here. If 9 is here, 49 is here. And our job is done. A pretty lengthy set according to me, right? But it was doable. If you are good at numbers, then you can probably do it. But there are chances of having mistakes in these kind of sets. Let's have a look at the questions now. What is the sum of all the numbers in the third row? So sum of all the numbers in the third row is 51 plus 50, 15 is 66 plus 10, 76. 76 plus 27 is 103. So option A is the correct answer for us. What is the maximum value of the number in any of the cells in the grid? Maximum value of the numbers in any of the cells in the grid is 51, which I see over here. So I think 51 is the correct answer. What is the sum of the values in cells 1, 4 and 5, 4? So 1, 4 is 49, 5, 4 is 9, 49 plus 9 is 58. How many numbers in the grid are even? So how many even numbers are there? It is 1, 2, 3, 4, and then 5, and then 6, and then 7, 8, 9, 10 numbers are even. My answer is option B. And lastly, what is the number in the cell 2, 3? So 2, 3 will be having a number 38. That is option C as the right answer for this.